Hi viewers, welcome to LMS Solution. Today we are going to see about microgrid and a dynamic operation with different MPPT. That means this microgrid consists of PV array and battery storage, and it going to be connected to the grid. This microgrid consists of PV system. Normally, in order to extract the maximum power from the PV, we will use MPPT algorithm. MPPT nothing but a maximum power point tracking algorithm. So here we are going to use different MPPT method and we have to check the result of the microgrid. Here we are going to use T into MPPT and then we have to use PSO-ANFIS MPPT and then we have to use PS Sliding Mode MPPT. We are going to use 3 MPPT and then you have to compare the result of the 3 MPPT. And first of all, I am going to explain that the system. This is a system, the PV array or PV plant. The total rating is around 1 megawatt. Here you can see that this rating of the PV panel. That means here you can see that the PV panel rating is 355 watts and then it have 15 panel in series and totally it having 190 parallel strings. When you click this plot, you can see the IV PV characteristics of the solar PV system. Here you will see that around it will be generated 1.01 megawatt at that peak power voltage around 651 volt at 1000 watts per meter square irradiation. You can see the different power level for different irradiation. It can generate maximum of 1 megawatt when that irradiation and temperature at a standard test condition. Then when irradiation at 1000 watts per meter square under 25 degrees Celsius. Here the boost converter used to boost the voltage, and then here the 3-level inverter, and that means neutral bind clamped inverter used for converting DC to AC. And this boost converter going to be controlled by means of MPPT algorithm. Here you can see that we have two kind of control. Just you have to concentrate on that MPPT. Here we are using MPPT. Here that MPPT algorithm used here. Here you can see that this is a PN2 MPPT. PN2 MPPT will receive voltage and current. Based upon voltage and current, you have to calculate change in power change in voltage, and then based upon change in power change in voltage, we have to calculate the duty cycle. That will be happen in the PN2 MPPT, and output will be duty cycle. So this output will be taken from that here. So it going to be control this boost converter, and then here you can see that PV inverter control. You have to measure point of common coupling voltage and current, and then DC line voltage, and then reference voltage maintained across this inverter. When you go inside, you can see that different detail, right? One is voltage regulator, another one is PLL, and power transformations. Here we are converting the actual ABC quantity into VDQ quantity by using power transformation. And then here we are using voltage regulator. It's in voltage regulator. Here we are comparing on the main reference voltage and then a DC line voltage, and it when we process we have PA controller, and then the final output of this voltage regulator is nothing but ID reference. And then here we are using only ID reference control. That means we are making IQ reference equal to 0. That means we are going to send only real power from the PV to point of common coupling. And here you can see here after that this will be given here ID IQ reference. Already we converted that IABC into IDIQ by using power transformation. Then here applying that to feed forward decoupling control concept. By applying the feed forward decoupling control concept, we are using that current regulator and feed forward decoupling control concept to generate the VDVQ. After generating VDVQ, we are going to convert it into actual form. That means ABC form by using inverse power transformation. Finally, you will get that V reference in the control voltage in the ABC form, and which process VFW generator that will be control this neutral point clamp inverter, okay, for converting DC to AC quantity, and then whatever power generated from the PV that going to be injected to the point of common coupling. This is a solar plant detail. Next you have to see about a battery plant. Here we have 1 megawatt battery system, and then it can supply maximum 1 megawatt hour. Rating of the battery here you can see that 922 volt, and then nominal capacity is around 1 megawatt hour, and then SOC of the battery initially is fixed at 50. Next here that we have that 2-level inverter. Here we are not using any converter, just you have to use only That means that battery is directly connected to the inverter. Just you have to convert DC to AC or AC to DC according with the condition of control logic, whether you go for charging or discharging, or based upon that converter going to be act like the converter or inverter. And then finally it going to be connected to the point of common coupling here. So here you can see that control of inverter. So this is a control of inverter based upon active power control and reactive power control. Next thing is here you can see that this is a local load, and then so here is the grid system. This point of common coupling voltage will be 600 volt, and then when we step up to 25 kilovolt, and then it's connected to the grid 120 kilovolt grid. After that here also we are step up the voltage from 25 kilovolt to 120 kilovolt, and overall system will be operated with 6 GHz. Here you can see that you can measure the point of coupling voltage as well as you can measure the frequency of operation here. So this is the overall system, and then you can measure the detail here. That means you can measure the detail of point of common coupling power, load power, power from the battery energy storage system after inverter, and then power from the PV as well as the reactive power from the battery side. So here you can see that detail, and also you can see the that point of common coupling current, load current, and battery side primary current, and PV side primary current. Here you can see that the results. So here only that means after simulating the model, you have to compare the result of this PV power with the other MPPT also. So next time I'm going to discuss about PSO MPPT. Here I'm going inside. Here we are using the fuzzy structure. The fuzzy structure we have created based upon PSO tuned ANFIS concept. The input will be irradiation and temperature. Output will be voltage, and it's going to be compared with the TV voltage, and again going to be processed a PA controller. It will be generate the duty cycle. So finally this duty cycle going to be sent to that boost converter to extract the maximum power from the PV panel. And also here we have that code. This is a PV model. Whatever model used in this, you have to take that reading, then you have to take the specifications. Here you can see that we are taking 8.68. Here you can see that short circuit current, current at maximum power point, open circuit voltage, voltage at maximum power point, and also you have to take the detail of temperature coefficients, and then you have to generate the random irradiation temperature data, and then we have to collect the voltage. Once you execute this one, and this code automatically execute that PS-ANFIS training model, finally you will get the fuzzy inference system that after training of this data by using P, you will get ANFIS structure in the form of fuzzy inference system. We have to use that fuzzy inference system inside that MPPT block. This is a concept we are using that PS. You can watch my YouTube video. Already I made some video about PSO-ANFIS MPPT. So you can check that video also. We'll get a clear idea about that one. Here we use that model. Here you can see this PSO-ANFIS code. First you have to run this code. After that it will be execute this code. Inside you can see that this will be trained automatically. Training process, everything will be happen. Next you can see that again here you mentioned this is the main code for a ANFIS training. We used to train that ANFIS. After that finally you will get a final ANFIS structure. So this only the ANFIS structure created from the that code, ANFIS code. That detail will be used inside. So here you have to use that inside the detail after training process. Next we move on with the sliding mode control. Here also we are changing the method here. Here you can see that here we are using PSO. The PSO will be generate the reference voltage. So the reference voltage going to be processed via sliding mode controller. So this is sliding mode controller, and the sliding mode controller will be generate the duty cycle, and then the duty cycle going to be controlled is boost converter. First you need to load the data once again. Now I'm going to simulate this one, simulating this PSO-ANFIS MPPT. Here you will see the results, and also here you will see that voltage at point of common coupling, and also here you can see that frequency at the point of common coupling with PSO-ANFIS MPPT. It will take some time for completion. We have to wait up to completion. Now we can see that right simulation is comes to end for PSO-ANFIS MPPT. So this is a response we are getting from a PSO-ANFIS MPPT. Here you can see it's a response of PV system for generation, and then here you can see this load power. This is point of common coupling power. This is reactive power from the battery side inverter, and then this is the power of battery side. This is for a ANFIS MPPT. Next move on to P&M. Here I'm going to execute that P&O MPPT. Here I'm going to execute that P&O MPPT. You can see the result here. Now you can see that the simulation started for P&O MPPT. It will take some time to complete. Wait up to completion of simulation. Now you can see that simulations almost come to end of the 5 seconds. This is the result with the P&O MPPT. Next move on to sliding mode MPPT. Here I'm going to simulate this model. It's compiling the model. It will take some time to complete the simulation. Simulation is not yet started. You have to wait some time. Now you can see that the simulation is started now. It will take some time to complete the simulation. Now we can see the simulation is almost completed for a PSO sliding mode. First you have to take the result of PSO-ANFIS, and then I'm going to take the result of PSO-ANFIS, and then I'm going to take the result of PO MPPT. This is a result of ANFIS, result of sliding mode MPPT, result of PO MPPT. Here I'm going to take a print to figure, and then I'm going to take only the PV detail, and then I'm going to create new figure, and then I'm going to paste here. This is for ANFIS. I'm going to change the color to red indicator result of ANFIS. The same way I'm going to click the result of sliding mode MPPT and print to figure, and then I'm going to click that PV result alone and copy that one and paste here, and then here I'm going to click result of P&O MPPT, print to figure, and then I'm going to copy this result. Before copying the result, I'm going to change the color to pink and copy that result and paste it here. Now you can see the result of P&O ANFIS and sliding mode MPPT. From that result you can see that the PSO MPPT providing the better results. Here you can see that PSO ANFIS providing the better tracking in MPPT, and also you can see here that it will take a long time. They have some problem in their tracking. PSO ANFIS is providing better result. From this result analysis, so we can conclude that the PSO ANFIS MPPT providing the better result than PSO sliding mode and P&O MPPT. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.